Okay, more theorems, more results that we can obtain from the axioms is what I want to go over now. So we have a proposition that says the probability of the complement of E is the same as 1 minus the probability of E. The probability of E complement is 1 minus the probability of E, which I think you would agree that is something that you would have suspected. So I have the Venn diagram here. So the yellow region within a ellipse is the event E, and the pink region is the event E complement. Of course, S is the sample space represented by the rectangle. Okay, so why is this true? Why is it that the probability of E complement is the same as 1 minus the probability of E? Can anybody tell me how I can prove this? So think about the axioms. Which axiom can you apply? And so on. By the way, the result of this result that we have proved here, that the probability of the union of E1, E2, En is the same as the sum of the probabilities of these events, right? This one. Well, when n is 2, how will this result look like? When n is 2, right? So let's say I have events E and B, two events E and B that are mutually exclusive, right? Well, then what this is saying is that the probability of A union B is the same as the probability of A plus the probability of B, right? If I have only two mutually exclusive events, the theorem that we proved says the probability of A union B is the probability of A plus the probability of B. If I have A union B union C, then the probability would be probability of A plus the probability of B plus the probability of C, as long as A, B, C are mutually exclusive. Okay, so let's come back to this now. How would you, somebody give me an argument why that's true? Could you use axiom number 2, which says the probability of S is 1? Okay, how are you going to use that?
Probability of S equals the probability of E complement plus the probability of E.
Very good. So let me, just for the sake of others, I think what you're saying is the following. First of all, you are saying that the sample space S, let me say the proof right here. So you are saying S is E union E complement, right? Obviously, E and E complement are mutually exclusive. So this implies that the probability of S is the same as the probability of the union of E and E complement. But remember I said probability of A union B, right? Which is a consequence of axiom 3. Probability of A union B is probability of A plus the probability of B, as long as A and B are mutually exclusive. E and E complement are exclusive, so I can say this is the same as probability of E plus the probability of E complement, right? So remember the probability of S is 1, right? So I get 1 is equal to the probability of E plus the probability of E complement, and hence the probability of E complement is 1 minus the probability of E. Very good. Is everybody clear?